Hello everyone, myself Atul Kumar, and today I'll be presenting my EL topic with title Microservices in Cloud, Azure Kubernetes. So I'm a sixth semester student in RV College of Engineering, and I have been guided by Professor Nagaraj Choli sir all throughout my semester. So let's explore how microservices architecture leverages Kubernetes in the Azure cloud environment. So this is my presentation outline. So we will start with the introduction of microservices. We will discuss the need for Kubernetes, explore its working, delve into Azure Kubernetes services, and conclude with a live demo. I'll show how actually we can use Azure Kubernetes. I hope to provide you all a comprehensive understanding of deploying and managing microservices using Azure Kubernetes services. Moving to the next slide. So at first, we'll talk about some introduction of the technical terms. At first, what is microservices? So microservices are an architectural and organizational approach in software development where software is composed of small independent services that communicate over well-defined APIs. These services are owned by small self-contained teams. So basically, it is a modern approach to building applications where we break down the software into small components and independent services. And each services performs a unique function and communication over well-defined APIs. Some key characteristics of this are that it's autonomous and specialization. The triads contribute to several benefits such as agility, flexible scaling, easy deployment, reusable code. These are some of the benefits that we get using microservices. As mentioned, the main characteristics of microservices are being autonomous and specialized. This is a symbol of Kubernetes. Uh, the question arises, what is the new need of Kubernetes? So the main importance of Kubernetes is that as we adopt different microservices, managing numerous services becomes a challenge. So that is where Kubernetes comes into play. It's an open source platform which automates Linux container operations. So being an open source, it helps in Linux container communication. The first point, uh, it not only helps in container communication, but it also simplifies deployment. It simplifies scaling for us and the operation of application uh, across the clusters of hosts. It helps with load balancing, rolling updates, and resource monitoring, ensuring that our deployment is efficient and resilient. So it helps in container communication. It helps in appropriate container deployment, in careful container management, and enable auto scaling. Moving to the next slide, here we'll talk about how actually the Kubernetes works. So as mentioned here, Kubernetes is a portable, extensible, open source container management which automates container deployment, container scaling, as well as descaling, and container load balancing. Uh, so here we can see that the master acts as the brain of the operation. There is a master that I will be discussing in next coming presentation slides. So that act as the brain of the operation, which manages the workload and directs communication across system. Here it's written on Golang. It is a huge community because it's firstly open source, and secondly it was developed by Google and later donated to CNCF. So it can group n number of containers into one logical unit for managing and deploying them easily. So this is some of the important points regarding working of Kubernetes. So as we can see here, we have a Kubernetes master which controls the cluster and the different nodes in it. In the picture, you can see that we have a node and different pods. Every pod has enclosed a container within it. The complete system is known as Docker. So nodes host the containers inside them, and containers are inside separate pods. What are pods? Pods are logical collection of containers which need to interact with each other for an application. There has to be an application, and the communication is directed via pod. Now there is something known as replication control. So replication controller is a master's resource to ensure that requested number of pods are running on node all. And service is an object on master that provides load balancing across a replicated group of pods. So as discussed, each node has some pods. It hosts some pods, which are the smallest deployable units created and managed by Kubernetes. A pod basically represents a running process on our clusters. So Kubernetes also uses various controllers like replication controller here to handle replication and life cycle management of the pods, and different services to manage network traffic and load balancing across the pods. So this is a complete overview of working of Kubernetes. We'll discuss about what is Azure Kubernetes. So when we talk about the definition, it says that Azure Kubernetes is a fully managed container management service by Microsoft Azure Cloud Service provider that offers serverless continuous integration and continuous deployment service. This is the representation of AKS, Azure Kubernetes Service. So Azure Kubernetes Service, or AKS, is a managed container service that leverages the power of Kubernetes on Microsoft Azure Cloud Service. It basically abstracts complex container management and provides cloud native capabilities. It's of course, it has serverless CI and CD, continuous integration and continuous deployment. One of the AKS main strength is its seamless integration with Azure DevOps. It can be integrated seamlessly with Azure DevOps, offering serverless connection. This means faster setup, more efficient scaling, and less overhead in managing infrastructure. So this is how the Kubernetes is defined. Uh, Next, we'll be talking about some working of Kubernetes. So we can see that here we have a control panel in AKS managed by Azure. It handles and schedules the Kubernetes cluster environment. It's responsible for orchestration, maintaining desired states, and scaling. The second are the nodes and the pods. So customer managed nodes run the workloads and communicate with the Azure managed control panel via Kubernetes. This setup provides a robust environment for deploying microservices efficiently. So we have two things, Azure managed and the customer managed. As the picture suggests, in Azure managed, we have control panel where uh, API is connected to control manager. There's a scheduler, and the scheduler is connected to Kubernetes. Kubernetes is the smallest unit of Kubernetes unit in Node, which is in synchronization with container runtime and the containers. So this is how the complete brief overview of working of AKS. Uh, so now in the next video, I'll be showing a live demo where I'll deploy a basic microservices application on Azure Kubernetes. I'll walk through the steps of setting up the services, how to register ourselves, and deploying the services and viewing its performance on the Azure portal. We can see the performance metrics there. So we can see that how quickly we can roll out changes and manage our applications at scale using AKS. So the last is the conclusion. So to conclude, I just like to say that using AKS for deploying microservices allows us to leverage Kubernetes' powerful features with the added benefit of Azure's cloud capabilities. This synergy offers a robust, scalable, and efficient way to manage containerized applications. So on next slide, I'll be talking about the demo. Thank you very much.